Hello friends, in today's class we are going to talk about scoping rule, that is nothing but visibility of a variable. Welcome again, and the next topic here is a scoping rule. Okay, so this is one of the topic concern in the examination, and also let me tell you that this is something related with accessing the non-local names. Okay, so the non-local variables, that is the key point here, and another key point here is access link. So we have already seen the this activation record, and here there is a access link, and which is something related with link to a non-local variable. Okay, so link to non-local variables, so that is something it is related with. Let's understand and let's read out. The scope rule of the language determine the treatment of the reference to the non-local name. So as I told you that this will come, that treatment to the non-local names, and the common rule is called the lexical or the static scope rule. Determines the declaration that applies to the name by examining the program text alone. Okay, so the first rule here in this case is your lexical or static scope. Okay, so that is one rule, that lexical and or let's say or static scope. The second rule is called the dynamic scoping rule. So the second rule here is the dynamic scoping rule. Okay, so the Pascal C ADA among the many language uses scoping, the static scoping rule. So there is a Pascal. Okay, so there is a Pascal like language, Pascal. Then we have a C, and then we have ADA that uses static scoping. Alternatively is the dynamic scoping and the current activation, Lisp, APL, Snowball. Okay, so these are the Lisp, APL, and Snowball are basically the dynamic scoping rule. So what exactly this static and dynamic scoping is about lexical or static. Okay, or static is about the definition wise. It says that most closely nested. Okay, most closely nested. So what is the meaning of most closely nested? Is this, that if a non-local variable occurs, okay, non-local variable occurs, then search the definition in next upper block. Okay, so that next upper block, and that is basically the meaning is most closely, okay, closely nested. Okay, so you have a block, this nesting of the block permitted. If you don't find anywhere, look at outside. Okay, that is a static scoping rule. And the dynamic scoping says that in case of undeclared undefined variable, in case of non-local variable, search the place from where the function is being called. Okay. So And here doesn't say dynamic scoping rule, the declaration, determine the declaration applicable to the name at the runtime. So runtime means we have to check that where it has been called at the runtime. Okay, so that applies to this the dynamic scoping, that where it is called from, and static scoping is most closely nested. Okay, so for example, for dynamic scoping is that if I have a main function, and in main function if I have a f1, okay, and in f1 if I have a non-local name, suppose int, okay, suppose I say print a directly in f1, and in case if a is print a, I say, and in case this print a is a non-local variable, then where it will be searched, no? So now the C will say that the static or C, this look at this nesting outside of this nesting. Okay, this is the rule, look at outside of this nesting, look at outside. Whereas dynamic says that where this f1 is called from right now dynamically, okay, and f1 is called from main, so look at the main, look in main. So that is the idea of your scoping rule, that one is out nesting is permitted, so look at the outside of this bracket, and another one is from where it has been called. Okay, so that's all. Thank you.